Well, hello everybody. My name is Pete. I'm a specialist solution architect with AWS, and I'm joined by Siyoung.
Hello, everyone. This is Siyoung. Thank you, everyone, for joining our AWS virtual workshop. For the next 5 weeks, we will be talking about how to get started on Amazon DynamoDB. For those of you who are new, Amazon DynamoDB is a NoSQL database built for scale. And it's a very popular database that's used for building applications that require key value data models and multi-region replication, as well as built-in security and backup. For the next 5 weeks, we will be walking you through a number of tutorials, and we hope that you'll follow along with us. And so, as a prerequisite, we hope all of you have an AWS account. If you don't, please use this time during our introduction to get your signed up for a free account. This series will run every Friday at the same time, starting today until April the 10th at 1 p.m. Pacific time. So let's continue. Just a quick introductions of ourselves. I'm Siyoung Ri. I'm a education manager on the AWS database team, and I own most of the training content and education programs on all of the AWS databases, including relational databases like Amazon RDS, non-relational databases like Amazon DynamoDB and Amazon DocumentDB, as well as some of the more purpose-built databases like Neptune for graph databases and TimeStream for time series databases. And then I'll hand it over to Pete to give a quick introduction of himself.
All right. Yeah, my name is Pete Naylor. I'm a specialist solutions architect for the Amazon DynamoDB team. Been with AWS about 3.5 years now. When I started with AWS, I was actually part of the enterprise account team supporting Amazon.com as a customer of AWS. So I worked with a lot of the internal teams, helping them with some fairly ambitious database migration goals that we had at the time. Learned a great deal about various AWS databases, but really fell in love with DynamoDB. And since then, I've rolled into this new role where I'm getting to work with a lot more of our external customers and helping them with similar database transformations. So I'm looking forward to talking about DynamoDB and working through this series. I hope that some of you will be able to join us for all of the episodes. Please do reach out with questions. Siyoung can help answer those, and we can discuss them. I'll try to allow plenty of time at the end of the session for questions and answers then too. So Siyoung, do you want to introduce the episodes that we're going to go through in the next 5 weeks?
Sure. We'll be going through a 5-week course, and we'll start from the basics, and then we'll gradually go on to more advanced topics. Today, we'll cover creating your first DynamoDB table, and if we have a time at the end, Pete will also walk us through a little bit more advanced scenarios in table creation, querying your data, and also resource cleaning at the end. And then in the following weeks, we'll go a bit deeper into how do you model your database based on access patterns for different applications such as gaming and mobile. And at the end of the 5-week course, the last course, we'll talk about building an actual modern serverless application using services like Amazon Lambda, API Gateway, and DynamoDB. And so we hope all of you will stay with us for the next 5 weeks and get the most out of our courses. Another one quick housekeeping thing is we'll try to use most of the services that are on the free tier. And so in most cases, it wouldn't incur any cost. But if we do, there may be a few services that use some of that. But most of the times, the cost will be hopefully under $1 for the sessions. And so we'll try to keep the cost at a minimum for this training course.
Great. All right, so let's move on to just talking about databases, tables, and some important DynamoDB terminology. I think we should start by agreeing on some basics. Why do we have databases? Well, we want persistent and durable storage of state, and we don't really want to take a dependency on storing this information on an application server instance, in a container, or within a function. We could use a simple storage service, right? S3, anyone? S3 is actually a pure key value store, and so is Route 53, actually. But these services only have the most basic of indexes. What if we have more questions about our data? Maybe we want to go group results in different ways, we want to retrieve them in sorted order, and apply a filter. Now we're really starting to talk about a database. Databases store information in a form that's optimized for particular needs. Some are built with an expectation of infrequent updates, but they are able to very efficiently build deep insights across vast sets of records. Think analytics or business reporting. Others are optimized for live interaction, where the questions are well known and often repeated. Updates can be frequent, and there's a need for features that prevent those updates from stomping on each other. Sometimes we have a strict requirement that when a record is updated, we need to see those updates right away in other threads or other application servers. And you may have heard of ACID compliance. That's atomicity, consistency, isolation, and durability. These are properties that are really sought out for that latter type of databases, for the transactional types of workloads. And this is really where DynamoDB fits best. So let's introduce some of that fundamental terminology for DynamoDB. If you've had experience with other databases, you'll see some similarities, but also some interesting differences that make DynamoDB special. Okay, so the first construct really is a DynamoDB table. Here's our table that we can see. It's just kind of an abstract that really just defines a set of information. In our table, we're going to have items. They're very similar to what you might have in many other databases called rows. And within those items, we're going to have sets of attributes, little pieces of data that typically you may be thinking of these as columns. What's interesting is that you can see that across those items, we don't necessarily have the same set of attributes or columns in every one of them. Some of them will not have those attributes, others will have them. What we do have to have, though, for DynamoDB is one of those attributes that we're going to call the partition key. And that partition key is what allows us to distribute the traffic or the load across multiple storage nodes on the back end. It allows us to scale without ceilings. We can also add or specify an optional sort key, which is the second one of those attributes. If we do define a sort key for our table, then both the partition key and the sort key must be defined for every one of our items. That partition key and optionally the sort key together become what we'll call the primary key. This is what we use to identify every item uniquely. So the partition key is really what we use for building or describing one-to-one relationships, key value in its simplest form. It also allows us to distribute the traffic, as I said, and to scale horizontally across a lot of infrastructure, as much as you need to satisfy the throughput you need for DynamoDB. It also identifies what we would call a collection. So the sort key, when we have a sort key for our table, allows us to build one-to-many relationships. And it collects related items under a particular partition key value. It also allows us to do some very, very efficient filtering. So this gives us a little bit of an idea about some of the functionality that we have for that sort key based filtering on a collection. We can make a query for a given collection to say give me all of the items in that collection, or we can say give me only the item which has a sort key which is equal to this value, less than this value, greater than, and so on. We can also use begins with, and we may get to some examples later today that demonstrate this, or also between. Now those results are going to come back in sorted order. We can choose for every time we make this query whether we want the order to be forward or reverse. We can also say we don't want to actually receive all of the item information. We just want a count of the number of items that match that specification. And we can also limit the number of matching results. So we can use this to say, I want the top N, maybe the top 5 or the bottom 10 items that match our query. Okay, so this gives us a
Pete,
little bit of the basics about DynamoDB.
Hi, Pete. There's 2 questions on the chat.
Yep. We
One
have
is,
some questions.
And the first one is, can we just use the partition key as the primary key? Pete, do you want to tackle that question?
I'm sorry, I did not catch that one. I think it cut out. Would you repeat that question,
Yeah,
Sion?
there was a question from Somya Pedada. Can we just use the partition key as the primary key?
So I think the question was can we just use the partition key for a primary key? And the answer to that is yes. You don't have to have a sort key. That's optional. You can build a table where you say, I want my primary key to only consist of the partition key. And in that case, we're really talking about having an ability to build one-to-one relationships.
Another question from Back Tang. When you mentioned one-to-one and one-to-many relationships, does it mean that DynamoDB can replace a relational database while it also supports ACID?
So one thing I would say is that oftentimes you'll hear about NoSQL databases like DynamoDB described as non-relational. And sometimes I feel like that's a little bit of a misnomer because every database is defining relationships. Even a one-to-one, a simple key value is relating one key to a value. And there's a lot of difference between relational technologies and DynamoDB. I think the biggest difference is for DynamoDB and NoSQL, we want to understand what our query patterns are ahead of time, and we're going to try to build our data and define our data in such a way that we can meet those query patterns. And in return for that flexibility, we get very, very consistent latency and a lot of scalability. So many of those relationships can be modeled for DynamoDB, and throughout the course of the workshop we'll go through a lot of those. It doesn't mean that DynamoDB completely replaces all relational database engines. This is why we have different database options within AWS, and oftentimes the best solution for a particular application might involve using multiple databases and serving the right kinds of query out of each particular database engine. I hope that answers the question. I think maybe further through the course we'll be able to answer that question in more detail.
Sounds good. Let's continue.
Do we have any more questions? Let's continue? Okay. All right, so what we're going to do here in today's part of the workshop is to use the DynamoDB console to build some tables and talk about what kinds of things we can do with them and how to make use of the console. So I'm going to switch over now, and we're going to start working in the console with a very basic table. Let me share my screen. Okay. So the first one we're going to create will be a really simple key value type of table, and the first and what you'll need to do to follow along is to log into your AWS management console, and then we're going to go and move to the DynamoDB part of the console. And if you don't have any DynamoDB tables already, the first thing you'll see is this splash page, where we do give you the option to click right here and create a table. You can either click there to follow along, or if you do have other tables, just move to the Tables tab here, and we have a Create Table button right up top. So we'll go ahead and click that Create Table button. And we're going to be required to provide two different things: the table name and a definition for that primary key. So let's assume that this table is actually tracking the state of some lighting devices in a home, maybe some connected lighting. And we're going to call the table lights. For our primary key, we just need a way to uniquely identify each light. So let's assume that it's going to be a text string, and we're going to call that ID. That's the name of the attribute we'll use. And that's really all we need at this point. We can go ahead and accept all of the other defaults and then hit Create. So we can see up top here, DynamoDB is creating our table for us, and there it is. It is ready to go. So we can see, first of all, that we have an Overview tab right here. I'm going to go back and just shrink this. And the first thing we see is an overview. So that includes some details that says our primary partition key, we called it ID. And we didn't define a sort key for this table. It's going to be a very simple key value database. But next thing we want to do is start inserting some data and put some information in our database. So we should create that first item, maybe a light fixture, and we'll just click the Create Item button to do that. And we're going to see that in the console here, we're going to see the attributes that, firstly, the ones that are required. So the attributes that are part of that primary key. In this case, it's just one, and it's ID. We're being told that it's a string. The first light that we're going to put in our database for tracking, maybe we'll call that Kitchen 1. And the important thing is, because it's a primary key, it must be unique. We're going to then click on this button, and we're going to append another attribute in our record. This we will call a number, and we will make this be the field will be status, and we're going to give it, maybe this light is currently turned, so we're going to say that this number 0 represents that the light is turned off, 1 would be the light is turned on, and we might even have some partial values for a dimmer switch perhaps. So let's say that Kitchen 1 is currently turned off. We'll make that value 0, and we'll go ahead and save that item. So now when we come back to this view of our table, we can see that it is updated to show us the list of items in our table. We can see Kitchen 1 is listed here with status 0, so we know that that's turned off. Let's add a few more. Let's say we're going to have Kitchen 2, the second light in the same room, and we'll append a status for it also. This light is turned on. We'll save that. Third light will also be in the kitchen. This is Kitchen 3. Status for this one is going to be 0.5. Let's say it's a dimmer and it's at 50% lit. Okay, so we can start to see these rows or items building out in our table. Make a couple more. Maybe we have a couple of controlled lights in our lounge. Lounge 1. and its status is 0. And maybe lounge 2. This will be our last one. We don't have any other connected lights in our house. And this one is also 0. Okay, so how's everybody doing? Feel free to follow along, enter in your own items, use different values, whatever you want to do. The goal here is really to get comfortable with the structure of DynamoDB tables and items and to learn to use the console effectively. So we have
By the
this
way,
data.
there were a few questions on the schema, and I think at this point we can introduce how DynamoDB is schema-less or schema-free. Some of you who have come from the relational side of the world would have noticed that when we created a table, we didn't define any instances or any data, any of those types of servers. And so DynamoDB is a serverless database. There's no need to provision, patch, or manage any software. You're not installing or maintaining or operating. Everything is serverless in terms of the database usage. Another kind of benefit to being serverless is that the product automatically scales up or down based on the traffic. And so for those of you who are new to this, it would be interesting to understand how DynamoDB works on the back end, and that for your applications, you don't have to worry about the traffic load or the or if you're getting throttled or anything like that, because all of that stuff is handled on the back end automatically.
Yeah, that's great. Do we have any questions we should answer before I move on?
And then another question from Arsalan is, does that mean DynamoDB is serverless and that there's backing up and restoring? Yes, there is backup and restores. In fact, there are two different types of backups. One is on-demand backups, where you can quickly take backups of your database as needed. And then there's also point-in-time recovery, where the database automatically takes backups 35 days in the past, and you can restore to any point in that time.
All right, great. How is everybody doing with the pace? For those who are following along and actually working with a similar table design, can I keep moving? Any feedback on that? Please let us know if we need to slow down or move faster. Okay, so we have this data. Let's say that we want to go ahead and actually we've decided to turn on this item called Lounge 1. So I'm going to actually click on Lounge 1, which will allow us to go and edit that. I'm going to go in and change the status from 0 to 1. And I can save it. And there it is reflected in our table. What happens, let's say we decide to get rid of Kitchen 2. Here's how we can delete a record. In the console, we're going to select Kitchen 2. And then under the Actions, we can select delete. Okay. All right. So that's the most basic of features within the DynamoDB console for managing items in a simple primary key table where we just have a partition key and no sort key. Let's go ahead and delete our table now, since we don't need that one anymore. We can just select the lights table and then hit the delete table button. I'm going to accept the defaults here and say that the nice CloudWatch alarms that the service automatically set up for me can go away because I don't need this table anymore. And I don't need to create a backup before deleting it either. This was just for example purposes.
By the way, Pete, there was a question from Anand. How do I add additional fields to the table once it is already created?
Good question. So again, getting back to that schema flexibility with DynamoDB, every one of your items can have a completely different set of fields or attributes, columns. You can go into an existing item and add new attributes. It might be an attribute or a column that doesn't exist on any other item in the table. Every item can look completely different, have a separate set of attributes or columns. The only ones that are required to be there are the attributes that are part of that primary key. So the partition key attribute, and if we're choosing to use a sort key attribute as well, then that must also be present. And the two of those two attributes coming together become that primary key. And it's the primary key that uniquely identifies an item in the table. So you can't have two items in the table with the same value of primary key of same value of partition key and sort key. They need to be different. Any more questions about that? So maybe we can go back to the slides briefly. And the next thing we're going to do is actually create a more complex table. But let's make sure we have answered any more questions. Did you see anything come by, Seung, that we should take time to address?
There are actually a fair number of questions in the Q&A window. Feel free to look at some of them if you feel that you want to answer those in real time. I have been answering some through chat as well.
Yeah, great. I see a question about the naming of partition key. Very often in NoSQL databases, we might call the partition key a hash key, and the sort key is sometimes known as a range key. So those are pretty much interchangeable terminology. There was a question about an example of a one-to-many relationship, and I think if we continue on and go to the next example we're going to work through, that will give you an idea of a one-to-many relationship and using a sort key. So in the next example, we'll actually create a table that has both a partition key and a sort key, and we'll work through some of the interesting query patterns that we can support with those. Okay, I'll go ahead and share my screen again. All right, so here we are. We're still in our DynamoDB console. I'm just going to shrink that out of the way. Okay, and we're going to again go ahead and create a table. So in this case, we're going to use a composite key table. So it has both a partition key and a sort key that make up the primary key that uniquely identifies each item in the table. And for this scenario, we're going to talk about logging data about mileage for cars that are used in a daily commute, and each day we want to record the miles that are traveled for each commuter car. And one of the needs that we have for our application is we want to be able to look at the history for each individual car. So what we're going to do in our table creation is, let's give it a name, we'll call it travels. And now we're going to define our primary key. In this case, because we're interested in collecting details related to each particular car, we're going to use the partition key as car ID. And we're going to add a sort key to our primary key this time. This is actually going to be the date, and we're going to make that a number field or attribute.
By the way, Pete,
everything. Yeah.
By the way, Pete, there were some questions on features. Maybe for this demo, can you unselect default settings and kind of explain some of the
Sure.
details that you could, some of the knobs that you can change when you create a table?
Yeah. Let's do that and take a look at some of the options. The first thing that you'll see when we move away from the defaults is an opportunity to build some secondary indexes for our database. So when we're creating our base table up here, we're going to represent the data in a certain way. We're going to choose a particular partition key and sort key, but each of those items has a number of different attributes, and maybe we want to be able to query that information in different ways. Maybe we want to collect them differently or sort them in a different order, use a different attribute. Perhaps we want to sort using the miles traveled versus the date, or maybe we want to sort based on the manufacturer of the car or the fuel economy expectations of the car. So we can, and we'll get into some examples of this further on in the series of workshops, where we can create secondary indexes for our tables that let us view and query that data in different ways. For now, we'll just stick with the base table, and really the base table is our first index. We have to have an index for that data. Another option that we have here is the read and write capacity mode. With DynamoDB, all of the storage that happens underneath the service is handled for you. You create a table and you push data into it, you can delete data, and everything just scales automatically for you around storage volume, which is a really nice feature, not having to worry about that and think about how big of a disk do you need and so forth. The other part of understanding DynamoDB and the way that we're handling your requirements is the number of requests per second that we're going to handle for you. So the number of reads and the number of writes per second. We have two different options for that. One is called provisioned mode. It's the original capacity mode for DynamoDB that really just gives you effectively two dials. One that says, I want you to be able to carry, X number of reads per second and Y number of writes per second. In addition to that, we can set up auto-scaling on that provisioned capacity. More recently, we've announced a new capacity mode which is called on-demand, and in on-demand capacity mode, you don't even have to think about those two knobs. You literally create your table and just start making requests against the database, and we will automatically, as a service, take care of scaling things on the back end for you to try and keep up with whatever kinds of increasing load you might experience. So by default, we just use provisioned mode, which is nice. It fits in the free tier, and you can see, because we've chosen provisioned mode, it gives us an opportunity to set a fixed number of read capacity units or write capacity units, and it also allows us to set some parameters for that auto scaling that I mentioned. The IAM role that is here is the one that's used by auto-scaling to do that auto-scaling activity for you. And then we have choices around encryption at rest. All tables in DynamoDB are encrypted in the storage. By default, we use an encryption key that belongs to the DynamoDB service. We have a couple of other options here where you can have more control over the actual encryption key that's used. And finally, down the bottom here, we can add tags if we want to. So for a lot of AWS customers, they want to be able to manage the resources that they're using in AWS using tags that kind of group things together or define maybe which part of the company uses particular sets of resources. So you can also tag your DynamoDB resources when they're created. So I'm going to go back and just simplify this, go back to the default settings, because for our purposes for this demo, they will work just fine. And I will go ahead and create the table. Again, we have our table name and our primary key specified. And that's all that's really required. Table is finished. being created. And again, we can see that in our overview tab here, now we have our table name. Our primary partition key is the car ID, which is a string, and our primary sort key is a date, which is a number. These are the many other options here that you can turn on around the scaling and backups and so forth. But let's just move ahead and think about adding some data in here and look into how we can start querying that. If we go to the Items tab again, and I'm gonna shrink this away here to give us a little bit more screen room. The first thing we can see here is, and maybe you noticed it earlier, is that whenever we make a change to the list of items through the console here, it's automatically going to use a call called scan. And a scan basically goes and gets every item that's in your table. It limits that for the sake of the console, because we really only want to see maybe 20 items per page. But that's what it's doing so that we can see the list of items that we've inserted. I'm going to go ahead and create some items. Let's say that car ID, call it car 1, on the 6th of October 2019, logged some miles. So you can see that because we have our primary key defined as having a partition key called car ID and a sort key called date, those were automatically placed in this create item box for us because they are required. It's part of the primary key, and every item has to have those. We can add some others though, and in this case I'm going to add a number, and it's going to be called miles. So this is the miles that the car traveled in its daily commute, and on that particular date we'll say it was 17 miles round trip. So we'll save that item. I'm going to continue to add some more items. This time it's a record for car 2, and it was the 7th of January in 2020. Again, we're going to choose to include another field that will be the miles that were traveled in this commute. We'll call it 12. Make that 12, yeah. So we can save that. You can see that we're starting to fill out our rows. Let's add another one. This one will be car 1 again. Another record for car 1, another commute logged. And this time it was the 1st of January 2020. We'll add this miles field. In this case, we're going to say it was only 2 miles. And we might choose to add another value here. So this is again where you can see that we have this schema flexibility. The other records we've already inserted didn't have any notes, but in this record we're going to add some. And it turns out that it was New Year's Day, but someone didn't realize it was a holiday until they'd started their commute. So we'll say here's a note that says they forgot the holiday. They left, got a mile from home, and turned around and came back. So we'll save that. We can start to see more information here in our table. Let's add just 2 more. This time we'll have car 1. Again, this one will be just a couple of days ago, the 10th of March. And we'll add that miles attribute. This one is going to be 21 miles. This is longer than most of the other commutes. We're going to add a note on this one too. This one we're going to say that they stopped at the store, so they had to go a little ways out of their regular routine. One more item. Car 2 again. Oops. Next one is the 12th of March. And again, we'll store the number of miles traveled this time, 13 miles. Okay, so now we can see all of our mileage records, and we're still relying on that scan to see every record in the table. But let's check out some of the enhanced querying we can take advantage of since we have this.
By the way, Pete,
yep.
There was a few questions that came up, and I think
Sure.
it's fair. Do we need to add items individually or manually one by one, or is there a better way to do this for, let's say, a real developer in a production environment?
Oh, yeah, that's a good question. This is obviously kind of slow work to go through, add all these items through the console. In actuality, each item that you're adding into your database does get inserted individually. We do have an ability to kind of batch those and insert 25 different items in one call, but we're working through the console here, and it's important to note that just like all of the other AWS services, we also offer access to this through the CLI. So you could certainly do this through a command line. You could script that. And we also have SDKs for a number of different development languages, Python and Java and Go and so forth. So if you were building any kind of real application, more than likely you're going to use those SDKs and programmatically insert these records. So, any more questions?
There was a question on can I query based on a column which is not part of a primary key?
Yeah, that's another good question. You cannot query on that. So this is one thing that is different about DynamoDB. If you've ever heard database administrators talking about unindexed queries and how inefficient they are, you cannot actually make an unindexed query in DynamoDB. In fact, the only way to get data out of the database that's not indexed is using the scan call, which basically returns every single item. And that's not necessarily an efficient thing to do. So this really comes back to understanding what your query patterns are going to be. And you build out your base table design to support that. And additionally, you can add secondary indexes as you need to. So while we had the opportunity earlier to add secondary indexes when we created the table, we can also add a secondary index later that will allow us to query our table on different fields. One thing we can do is, in addition to using the condition that we set on the sort key, there's also another filtering expression. So once we've gotten our result set back from the partition key and sort key, we can also add filtering for other attributes. And I think we'll get to an example of that either later today or further in the series. Hope that answered the question. Was there any more, Young, that maybe I should touch on?
And I guess a few questions on joins in general. Does DynamoDB or any, I guess, key value database in general support joins? And if not, what's the best way to address these types of queries?
Yeah, so if you think about in a traditional relational database, we often design things in what's called a third normal form. We break everything out into entity types into its own kind of table, and then we use the CPU to go and get different pieces from different tables and kind of build the relationship between them and give us the results we want. And that's really a powerful thing that has worked mostly to reduce the overall storage volume, going back 20, 30 years ago when relational databases really took off. Storage was incredibly cheap, and the data sets were a lot smaller than many people are dealing with today. And CPU was relatively something that people could burn. Flip things around to now where sometimes people are dealing with really big data sets. storage has become a much lower cost, far more scalable thing than it was going back, those decades ago. And CPU has become the thing that, especially when we're talking about vertically scaling, can really be a limiting factor. So what we're trying to do in these NoSQL types of databases is denormalize where we can take advantage of that. So essentially, we can use things like that schema flexibility to try and pre-build all of the answers we want. We're pre-joining everything that we want, and we're going to store every single possible answer, because now we can go in and request each record, and we don't have to wait for a CPU to build or do all the joins and build that. It's literally coming off a very high-speed storage device. And this is part of how DynamoDB achieves its really, really consistent low latency and scalability. So hopefully I've dug in on that a little bit. It's a big topic, and again, probably we will talk about this in more detail as we get further through the workshops. Have one more, Siyoung, or shall we move on?
Yes, there's a bunch of advanced questions coming in. I think we'll save those for the future workshops where we'll talk more about secondary indexes, global tables, and more complex queries. So stay tuned for those.
Okay, that makes sense. All right, so going back to our example here, we can see all of our mileage records, and we're using that scan to see all of the records. But let's try switching this to use a query. This is a different kind of call we can make for DynamoDB when we have that sort key. What we want to do is query and get all of the records for car 1. So in this case, we can say our car ID is car 1. And we're actually not going to specify any kind of condition on the sort key. We'll just go ahead and start search. And we can see that now we're only going to see the records that are related to car 1. So what about, we can actually, another option we can see is they're sorted, right? We can see them in ascending order. If we wanted to, we could repeat this, saying we want it in descending order, and search again, and we'll get them in the opposite ordering. So how about if we only want to see car 1 commutes that are in 2020? We can go up here and again leave the partition key as car 1, and the sort key we're going to say greater than, so this is the date, we're going to say greater than 2019 12/31. And if we now search on that in ascending order again, we'll see that we're no longer getting the 2019 records, only 2020. So how about, again, more querying options? What if we want to see the car 1 commutes that were between November 1st and February 1st? So we'll search again, and there was only one record. It's the day that we forgot it was a holiday. So we can additionally apply, and again, this is coming back to some filtering. If we wanted to place an additional filter on this, let's say we want to look for car 1 commutes that are in 2020 and that have notes. So we can say, again, we're going to look at the collection of records that are for car 1. We're going to say it's greater than, or actually let's say we want it in 2020, we'll say from 2020 12/01, sorry, make that January 1 and 12/31. That gets us pull just the 2020 records, but let's add another filter to that by clicking the Add Filter button. And you know what? Let's look for one that has the notes that include something to do with holiday. So now we're only seeing that one record. So you can start to see that there's a lot of flexibility in the querying, and we want to do the bulk of our filtering using that sort key condition. But we can also add filter conditions on top of that to get much finer result sets. Okay. So now we've seen some of the power of the query call, and we can go back and perhaps take some more questions before we move on.
Yeah, there was a question on by Robert saying, if I want to query for all cards, what value do I put in the primary key search string?
So that would be the thing. There's no way to query for all cars except that we know that all of the items in that database are car related. Now we can scan and get every record back.
And another question from Carl is, what are the best practices for storing date-time data?
So there's a number of different patterns there. One would be that you could store it as a string in ISO format, or you can do it numerically. And usually you're going to want to search in numeric sorted order. So as you saw, I created the date with the year string first, and then the month, and then the date. It really comes down to knowing what your query patterns are going to be when it comes to choosing a sort order or a date format. It might be something that I could work in an example of for one of the later workshops.
Question from Rich. Does DynamoDB have the concept of a like search?
No, it does not have the concept of a like search. That would be something you would either have to do, so we can see here the different options that we have for a filter expression. There is no like equivalent in DynamoDB. For something like that, like doing full text search type activities, very often we would pair up DynamoDB with something like Elasticsearch.
Another question is, can we export the result set into a CSV Excel type file?
We can a number of different ways on an actual large table. I think we actually have an option to do that in the console somewhere, but perhaps not.
I know there are third-party tools that do that, so a quick Google search should be able to find tools that help with that.
Yeah, definitely one of the easier ways to do exports of DynamoDB tables is using one of the other tools like Data Pipeline. There's actually a template in there for exporting a DynamoDB table into S3 or to import from an S3 object into DynamoDB.
Question from Israel. How do you specify null or not null values?
Null or not null. So you can actually, there's a data type that allows you to do that. Maybe we'll create an item and see what's possible there. We'll do car3 and 2020-03-13 today. See what we can add. We can actually add a null field here. The other option, of course, is just to leave the attribute out. But you know, admittedly, there is a difference between having a null value and just not having an attribute. Depending on what you want to store, you know, having a null attribute might mean that someone had actually filled in a value for that attribute before and has now deleted it, and that would be an indicator that it used to have a value. but there's plenty of flexibility around data types there.
Okay, and I guess let's answer one more question before we go to the next one. How does filtering performance scale with the size of the table?
So the size of the table and depends what you mean by filtering. If you are using a scan, basically if you were to place a scan on a table, scan the entire table, and then want to put a filter on there that says I want only records that have the word holiday in the notes. That would be something that would be quite inefficient if you have 100 million records in there and only 5 of them have holiday in the notes. You're going to essentially read all of that data off disk and then apply the filter. That would not be a recommended way to model the data. Ideally, you'd want to index that better. So you could then make a query that's more efficient in that regard. If you do the bulk of your filtering, let's say like I've done here, where car 1 might have 5,000 records and only one of them, you're looking for a certain date range, you would use that sort key condition to reduce the overall bulk of that, and then hopefully you're not having to sort through so many records. So definitely when you're developing your data model, you want to be able to build queries that do the bulk of the filtering using that sort key condition, and then use the filter expression to do your final narrowing down on that.
Since there's a large number of questions actually coming in, let's do a few more before we go to the next section.
Sure.
A question from Badri is, can I apply filter for non-index or non-sort index key? I see we were able to filter on notes. That is neither a sort key or index key.
Yeah, so you can do filter expressions, and you can see the difference up here in the top where we're doing this. We can do sort key conditions that are applied against the sort key. We have to specify a partition key value. The filter expressions that we're adding here can be applied against any other attributes, any other columns. So those are much more flexible, but also not as efficient.
And then another question is, does DynamoDB have the concept of distinct?
Distinct. Maybe by that you're like adding additional unique keys.
Yeah, I think the question was on unique keys, if you can.
Yeah, so usually we're having to specify that or use that by basically having an item with a primary key which is unique. One thing that we have seen more recently is if you have multiple constraints that you want to apply around uniqueness, we can model for that using DynamoDB's new transactions features. And again, this is getting a little more advanced than we were planning for this session, but you can essentially insert 2 items as part of a transaction and make sure that both of those are unique. So for example, if you were tracking users for your application, you could both confirm that the username is unique and their email address is unique by inserting those as 2 separate records and make them part of a transaction. So they must either both succeed or both fail.
Right, and then there's 2 other questions related to, isn't contains similar to like, since you just showed that?
Contains is a little different because there's things like pattern matching in like that are different than contains.
Right. And then last question before we move on. Is there any query optimized options like relational engines? And I'm guessing we'll probably cover some of the access patterns later in the course.
Query optimized. I'm not sure I'm fully understanding that question, but I think probably where we're leading to there would be using additional indexes to be able to query in a more efficient way. Usually we're going to, with DynamoDB, build out the base table to cover our most frequent or basic of design patterns. or access patterns, and then we would add probably a global secondary index in order to support the other secondary query patterns that we need to offer for our application.
Okay.
And we really
Yeah, let's continue to the next section, and then we can cover the questions after that one.
Sure. Yeah. So I'm going to move pretty quickly on the next one because it will take me longer to insert more of these items. The first thing I'm going to do, though, is go back and delete this table because we don't need it anymore.
I think it will help if you share your screen too, Pete. Thanks.
Yeah. All right. So I've deleted the table, and I'm going to move that out of the way. We'll go back up here and click Create Table again. This time we're going to use the database to store some media details, books and albums, along with the author or musician and the chapters or songs. And we want to be able to efficiently update and retrieve information about the book or the album itself, lists of chapters or songs, or just one particular chapter or song. So let's create a table that might help us organize all of this effectively. And we'll call that content. And we're actually going to store a number of different types of information in this table. So we might as well keep the partition key and the sort key names generic. PK and an SK, that will do. And so we're going to leave all the rest of the options at their defaults, and we'll go ahead and create that. And I'm going to slide this out of the way so we have more room, but our table is ready. We can go and start working with some items. I'm going to create a book first, and I'm going to use a book ID number as 1234. And you'll see that what I'm going to do is use a prefix. I'm going to use b hash, 1234. And that's to ensure that it's going to be unique, and it won't conflict just in case we have an album that we're inserting later that also has an ID number of 1234. And we might also be able to use these kinds of prefixes for some interesting patterns that are coming up in the future episodes, where we can build additional indexes and make use of some of that querying functionality. So the first record we'll enter for the book is some metadata, so the details about the book itself. We'll make the sort key actually be the same value as the partition key. We're going to add some more details. We'll add some more attributes. We'll have a string, and it's going to be a book. We'll have the book title here essentially. So we'll call it Living with DynamoDB. Maybe we'll add a number that is the published date. Let's say that was published 2020-0301, and that will do. So that's our basic record talking about the book itself. We'll add another item here. This one will be one of the writers. So again, this is related to book 1234, but the sort key this time will be the identity or the ID number of a writer, and we'll use a prefix for this also. It's writer number 12, and we'll add a string which is the writer. The name is Seyoung. Maybe let's have a second writer. This one actually Seyoung and sorry. That's not what I wanted to do, so we'll remove this. Okay, so we have our writer who is C. Young. We'll save that out. I'm going to create a second writer because they teamed up on this book. Writer number 13. And this will be Colin. Oops. And we'll save that one out also. So we're starting to see that we're building this collection of records that are all related to book number 1, 2, 3, 4. Add some more details. This is going to be describing chapter 1. So we'll use that prefix pattern again. And we will add a string that's called chapter. This will be chapter 1. And it's created a table. Maybe we want to also track the number of pages. It's just going to be one page because it's pretty easy to create a table, right? So let's save that. Another chapter. Chapter number 2. This one is scaled elastically and automatically. Again, put a number of pages as 1. One last chapter. Or no, let's do 2 more. Be 1, 2, 3, 4. Chapter 3. This one is going to be innovated in the application. 3 pages on this. Seems like a bigger topic. So our last record we'll make for this particular book will be description of chapter number 4. And prospered. One page. Okay, so we can start to see our book here. Maybe what we'll do next is we should probably add an album. And this album is going to be the identity of the album is 4321. Again, we'll have a record that tracks the information about the album itself. We'll do a string album. My old database. It's kind of a sad album. It might be country western. And we'll have a release date. All right. We'll just have a few. Let's see. Album 4321. This time we're going to have a record for the musician. And this is going to be Pete. We might actually, maybe maybe there's a band. We'll do a 321. Musician number 26. We're both involved in this, so we'll do. This is the backing band, the Dynamosters. Right, we'll add 2 songs to this album. This will be a song, so we're going to give it a prefix of S. And the song title is going to be the song Tried Calling But You Weren't Available. Let's add a duration, kind of like the page numbers we had. We'll have a duration in seconds. So this might potentially be something that we could sort on later if we wanted to build indexes around that. One more song. Oops. Number 2. Our relationship peaked. Now I can't scale that back. Alright, and we'll add a duration for that also. This one's a longer song, 218 seconds. Okay, so we can start to see there's a bunch of different columns here. Again, you can see that the different types of items in this table don't all have to have the same set of attributes. They all have to have a partition key and a sort key because we need the primary key. But they can be completely different types of items or different relationships that we're recording in here. We can also have two different types of entity in here. It's not like we're having to create a separate table for albums versus books. And that might be really useful to us later. Maybe we want to build an index which is across both albums and books to sort or to be able to sort on the writer or to be able to find particular artists. So let's look at a few different examples we could make there just so we can again try out our querying. We'll switch from a scan to a query, and we're going to maybe say, give me all of the information about book number 1234. So we'll specify that collection. We're not going to give a sort key condition or a filter. We're just going to start our search. And you can see here we've immediately narrowed that down to the one collection that is related to that book. How about, let's see, what about give me the details about album 4321 itself. So we don't want to get any other records. We don't need the songs or anything. We just want to get the information about the album itself. So for that, we're going to see this, say the sort key is also album 4321, and we'll search, and that's all of the information that we get back. We get exactly what we're looking for. What about finding all of the musicians that are involved in producing album 4321? So in this case, we're going to change that. We're going to say the sort key must begin with M hash. So that's where we're using that prefix to be able to sort for particular types of records or relationships. We'll search here, and there we go. We get Pete and the Dynamosters. What about all of the chapters in book 1, 2, 3, 4? Begins with, and again we had that prefix of C for chapters. Let's try searching on that. There they are. They come back in sorted order nicely for us. We can switch that sort order if we want to, very quickly and easily. And there we are. So this gives us a little bit more insight into some of the ways that we can model our data in order to support particular query patterns. And these are obviously fairly contrived scenarios. We definitely build data models for very, very much more complex sets of relationships and query patterns. But the goal here was just really to demonstrate the features in the console for adding and updating items, deleting items, and also to be able to use the query call from within the console here with sort key and perhaps filtering. Let's say maybe we want to add a filter on the number of pages being greater than 2. And we'll go back to ascending order. But there we go. So there's a lot of flexibility there. Again, when we're using a filter expression, it's not as efficient as being able to build that into a sort key. So that's something to keep in mind. You want to do the bulk of your filtering out of the actual items in the result set using a sort key. That's a very much more powerful construct within DynamoDB. But we can definitely use the filter expression as an add-on to that to further narrow down our results. All right, and that's the end of that demo or that workshop. I hope some of you were able to follow along. I know I moved pretty quickly there, but it's very easy to go into the console here, play around with some different table ideas, add some items, use the query tool to see what kinds of query patterns you can make, sort key conditions, and so forth. I'd encourage you to play around with that. And in the future sessions in this workshop series, we'll work through some more complex scenarios and build some different data models. So the last thing I'm going to do here is go back and delete this table.
There were also a few questions on the chat.
Sure.
First one from Adesh. The local secondary index needs to be added at time of creation. What if you need to add a new local secondary index after table is created? What's the best suggested way to do this?
I'm just going to stop my screen share and come back, maybe come on camera to answer some questions. All right, I'm back, I think. Yep, and I think there's Siyoung. Awesome. So the question was about local secondary indexes. And so we have two different types of indexes for DynamoDB, two different types of secondary index, I should say. One is local secondary indexes and one is a global secondary index. Local secondary indexes do have to be defined at the time you create the table. And they also have the restriction that the partition key must be the same as the partition key of your base table. So they're not as flexible as a global secondary index. Really the question to ask there is, do you really need a local secondary index, or would a global secondary index be a better fit? A global secondary index can be added afterwards. It's an online index building process. You can add that in and delete it if you decide you don't need it later. If you did build a table that has a local secondary index, you're somewhat committed to that. If you really wanted to get rid of the local secondary index or add additional local secondary indexes, you'd really have to come back to creating a new table. What questions do we have here? We have about 10 minutes left. Did you see any, Siyoung, that think we should
do a few. Is there a recommended max to the number of attributes in a collection?
Number of attributes in a collection. So no, there's not really any kind of restriction there. There is a restriction on the overall size of one item, one row in DynamoDB, and that's 400 kilobytes. You can have that 400 kilobyte item could be made up of as many attributes as you can fit into 400 kilobytes. And then, of course, if you build it as a collection, now you have multiple items. You can have as many items in a single collection as you need. The only small restriction there being, if you did build a table that has local secondary indexes, the size of a collection, so the full set of items in a collection, so all of the items that have different sort keys but the same partition key value should not exceed 10 gigabytes. If you don't have local secondary indexes, your collections could be terabytes, if you please.
Right. And is it a good practice to store multiple entities in the same table? And are we going to do this in the future workshops?
Different types of entities. Was the question, is it a best practice or is it a common practice? Sorry.
Is it a best practice, I guess?
So yeah, that's a good question. I mean, if you've watched some of the other DynamoDB related content out there, we talk a lot about single table design, and really where we're headed there is encouraging people, especially if they're bringing a lot of relational experience, which many people have, and starting to look into designing data models for DynamoDB. If you bring that third normal form where you just naturally create a table for invoices and a table for customer and a table for addresses, then you're basically kind of not taking advantage of the denormalized patterns that are very scalable in NoSQL databases like DynamoDB. You're also missing the opportunity to build collections of items. So, you can't do that kind of query across a collection if the items are actually in different tables. You can't build a global secondary index across multiple tables. So the choice there is really, or the way to approach that is to think about how do you want to query your data first. Start with one table, build out what you need. Fewer tables is always a nice thing in terms of the operational things that you need to take care of. If this was an important production service, you would probably want to have alarms and dashboards and keep an eye on the capacity and so forth. If you do that for more tables than you really need, then now you're multiplying the number of things you have to take care of. So reducing the number overall is probably a good thing. Having said that, we do see people using multiple tables for completely unrelated different types of entities that are part of the same application, and that's also fine. One of the things that you can think about is that if you have some kind of a need, like a transform and load into a data warehouse, for example, and maybe you want to get all of your invoice records, but you don't want to get the customer records. You would often do that using a scan, and so putting the invoices in a separate table makes it possible to scan just the invoices and not scan the customer records. So there's pros and cons to that. I think where I would be headed would be the least number of tables that I could use for my data model that support my query patterns.
Another question was, Azure Cosmos DB has 5 levels of consistency while Dynamo has 2. Is there a way to have similar consistency levels?
So DynamoDB offers 2, eventually consistent and strongly consistent. And one of the things to note about the way that eventually consistent works is every record, every item in a DynamoDB table is actually stored across 3 AZs and 3 separate storage nodes, and that's for durability and availability and so forth. When you make a write or you make a strongly consistent read, it always goes to the leader of those 3, and so you're dealing with the very latest item. When you make a write, we don't confirm that that write has succeeded until we know it is durably written to 2 of those storage nodes. So when you make an eventually consistent read, you go to one of the 3. I can't really comment, to be honest, on Cosmos because I don't know what the 5 levels are or would be. But certainly in DynamoDB, having those 2 choices of eventually consistent or strongly consistent for your reads offers a number of advantages for folks, and we always encourage them to firstly, use the default of eventually consistent reads, but when you need strong consistency, it's there as an option.
So I guess last question before we go to so I guess we're transitioning to polls now. For the questions that we weren't able to answer today, we'll save those and we'll try to answer them in the next session next week.
Thank you to our presenters and our moderators for their time. On your screen, you will see a few live poll questions. Please provide us with your feedback by clicking the radio button next to your reply for each poll and typing in any feedback. I will now hand it back over to Pete and Seyoung to take several questions in the time we have remaining. Please continue to submit any questions you may have, and we'll try to address as many as we can.
All right, I see a question about is update and delete supported in DynamoDB from Satish, and it definitely is. When you're making an update call or a delete call, or I should just say the update call, it's basically an upsert. So we're always just, when we're rewriting an existing item, we're writing over the top of it. When we use the update item call, the difference there is that we can specify just particular attributes that we want to change to some new value. And when we do that, all of the other attributes and details will stay the same as they were, and just the attributes we mentioned in the update call will be changed. You can also definitely delete items. You can either delete items, or if you just want to delete certain attributes within an existing item, you can either use the update item call or use the put item call and rewrite it with the attributes removed. There's another question about, can I get only some attributes on the query? And the answer to that one is yes. You can also, when you make a query or a scan or a get item, or even a batch get items, those kinds of calls, you can certainly specify you only want to get particular attributes, and in the result set that's returned to you over your connection, you'll only see those attributes. I'm looking for more questions here, trying to keep up. So does the 400 kilobyte, where's that? Does the 400 kilobyte item size limit include the size of any binary attributes as values? Yes, it does. And in fact, the 400 kilobyte item size limit also includes the size of the attribute names themselves. So one of the things that you'll see, for example, in my last workshop or demo that I did, was that I chose to call my partition key and sort key attributes PK and SK. I'm trying to keep those short because basically that's going to be recorded for every single item in the database. And it doesn't really make sense to have an attribute name that's called this is the partition key, because that's going to use more storage and be less efficient. Wonder if there's time to do one more question here. Can you have more than one sort key? No, just the one sort key specified for the primary key in a composite key table. You can definitely, obviously, use that as a generic column name and insert multiple items that can be sorted in different ways, kind of as was demonstrated in the content example there. I think maybe that's all that we have time for today. We can close it out there. Thank you very much for joining.
Thanks, everyone, and we'll hope to see all of you at the same time here next week. And I will be sharing the URL for those of you who lost the URL for the registration in the chat window. So feel free to go there and register for the other courses if you have not done already.
Great. All right. Goodbye, everybody.
Thanks, everyone. Bye now.